Hello, welcome to Introduction to MATLAB. In this lecture, I will introduce you some of the basic functions of the MATLAB. So, MATLAB software can be downloaded from mathworks.com website. So, if you go to the mathworks.com website, then what you can do is you can click here on this Get MATLAB button, and then you will have various options. So you can try the MATLAB for 30 days as a free trial, or you can get the campus software. So I have found that our university has the campus software for this. So you can click this option, check for access. Here you will put the university name and your email address, university's email address, not your personal email address. Okay, and then you will submit. You will get an email for the confirmation, and then from there you can do the follow the steps, and then you can install your MATLAB for software. Okay, so that is just a brief way how you can get the MATLAB software. Okay, so when you get the MATLAB software, you can see it's you can open it, and then you can see its interface. So depending on depending on how you install and then configure your MATLAB, you can have slightly different view. But the main view for working on in the MATLAB is this view. Okay, in this window, this is the command window, which is the main window in which you will work. In addition, you may have a few more windows. So for example, this window will be the current folder. That means the folder in which the MATLAB will save your files if you wish to do so. And then there will be a workspace window. So I will I will tell about these windows later on. Okay, let's do some operations on this command window. So you can perform some basic operations, arithmetic operations. For example, 4 plus 5, and then if you will enter, you will get a number, the answer as 9. 7 times 8 is answer is 56. Or if you can perform some trigonometric functions, so for example, cosine of 0. Okay, so then enter, then you will get the answer as 1. Okay, so these are the simple mathematical operations. We will look at these a little bit more about later on. If you there is a very useful command which is which we'll often use is the CLC. So CLC command will do is it will clear the screen. Okay, so whatever will be on the in the screen on the command window, that will be cleared. Okay, so I have cleared the screen. So let's do this calculation again. 4 plus 6 is 4 plus 6 is equal to 10. So I get at a like ANS is equal to 10. ANS is the default variable name for the calculation which you perform, but we can assign this 10 to some any other number, any other variable. So for example, my variable is my sum. My sum is equal to 4 plus 6. So in this case, my sum is equal to 4 plus 6, that is 10, will be assigned to a variable name my sum. And now I can use this variable for further calculation. So for example, now if I want to square this, so what I want to do is that I can take my my sum, okay, my sum, and then if I want to square it, and then I can put it like this. So now the answer will be 100. So in this case, I can use the variable name to store the value of the calculation. Okay, now you can see that here we can see in the details window, I am getting some values over here. So here I am getting some variables, names, ANS, and my sum. So my sum was the sum of 4 plus 6 is 10, and the ans was 10 before, but since I have updated it, so its ans ans is now 100, and its class is shown as the double. So double means over here is the double precision. I will talk a little bit more about it for the class later on. Here what I want to show you is that if I want to if I do some CLC command over here, the values, all these calculations or the values have been removed from this workspace, but these values have not been removed from this workspace. So if we want to remove these values from the workspace, what I can do is clear, okay, ANS. Okay, so then ANS will be removed from the workspace. Or if I want to remove my sum from the workspace, then what I can do is I can also right click over here, and then I can hit the delete button. Are you sure want to delete the selected variable? Yes, I can delete it. Or let's do some more calculations. So 4 plus 6 is equal to 5 plus 6 is equal to 11, and 6 times 330 is equal to 180. Okay, so now if I want to remove everything from my workspace, or maybe I define another variable t is equal to 7. Okay, t is equal to 7. So now I have two variables, ans and t over here. So if I want to remove all, so then I can put the command clear all, and then everything will be removed from the workspace. And now I click the CLC, and the screen will be also cleared. So with this brief introduction, let's look at this current folder. So in the current folder will show you the folder which you have selected, and then that folder will be used to create your file. If I right click over here, so then I can do some things as that. So if I click new, I can use this folder to create the new script or function, an example class or zip file, etc. I will not do many things over from here, but mostly I will I will create the script and function later on in this course. Okay, so but I will keep for use for later on. Another thing is that my MATLAB also stores the history of the command which I have entered. So in order to go to the history of the command, what I can do is I can press the up arrow key on the keyboard. Okay, up arrow key. So for example, if I click over here and make the command window active, and now I click the up arrow key on my keyboard, so then it will show all the commands which I have entered previously. So for example, if I want to go to this command 5 plus 6, so I can just go it, and then I hit enter, and then the command will execute over here. Want to see this history command history window, then I can go to this layout button, and then I can click at the command history, and then maybe I can select the docked option. So in the docked option, then the command history will come over here. Okay, but of course, but at this moment I don't. So this will show you all the command history, but actually I don't want to show it over here right now. I don't really need to show it over here, so I will select this option of docked option off, and then I will click the popped option over here. Okay, so when I select the popped option, then it will be it will only pop up. Then I will select the then I will hit the up arrow button over here. Okay, up arrow button on the keyboard. One of the use for the history is that we can recall the history of the commands, and then maybe if we want to edit some of the commands. So I can just go to that command and then I can edit it. So for example, initially I used my sum is equal to 4 plus 6, and maybe instead of my sum is equal to 4 plus 6, I want my sum is equal to 4 plus 4, and then I can edit and I can execute it. So this is one of the use for using the history of the commands. Okay, now I want to show you how we can create some of the variables in MATLAB. So basic variables are three kinds: scalar, vectors, and matrices. And of course, there are some more variables as well. So first of all, let me clear the screen. Uh, Clear the screen and also clear the workspace. So clear, I will put clear all. Workspace have been, you can see that the workspace have been cleared, and I will put CLC, and the screen has been cleared. So just to make the area tidy, so I have done, I have done like this, right, to use CLC and clear. So for example, if I want to create a scalar, so scalar is any number, okay? So my number, okay, so this will be a scalar, okay? So if I assign a number is equal to 8, okay, so my number is equal to 8, so that means if I execute this command, my number is equal to 8. So this will be a scalar, okay? Yeah, now right now I will show you also that if I put my number is equal to 8, and then I append a semicolon over here, and then I hit enter, then I will see that the command will execute, okay, and but you can see that it will not show the result in the command window, but in the workspace it will show that the command has been executed. So has been executed. So maybe I will try with another number. My number 2 is equal to 7, my second number, okay, and then I put the semicolon, and then I click enter. So in this case I can see that my number 2, the result has not appeared in the command window, but it has appeared in the workspace. Okay, so we use these semicolons in the command windows to suppress the results, because that result are maybe the intermediate results that we may not need it to show. So just to save the space and keep the workspace tidy, so we can use these semicolons, okay. So this was about creating a scalar. So we can also create the vector. So vector, we already know that vector can be a row vector or can be a column vector. So it is the combination of it is a set of the numbers. So for example, I create a vector, so maybe I called as the first vector, okay. First vector is equal to maybe a row vector. So for the vector I will put the bracket, okay, and then I will put the members of the matrix. So for example, the members of the matrix are 2, 4, 5. So you can see that I have put numbers 2, 4, and 5 with a space between them, okay, with a space between them. One thing I want to show you is that you can also put a space between equal and this as well, or even if you don't put a space between equal and this, it doesn't make anything. It doesn't make any difference in the MATLAB. So just for the clarity, you can put a space, otherwise there is no need to put a space. But however, if you want to define this vector with members 2, 4, 5, this is a row vector, then you need to put a space between 2, 4, and 5, or in another case you can also put a comma as well, but space will be fine. So in this case, my first vector over here is shown as 2, 4, 5. So this is the row vector. If you want to define a column vector, So column. So for a column vector, so this is the variable name column vector. We'll put the brackets, and then in the brackets you have to, so suppose I want a 3 by 1 column. Okay, so 3 rows and 1 column vector, so maybe 3, and in this column vector we have to separate the members of the column by a semicolon. Okay, 3 comma 3 semicolon 2 comma 6. So for example, if this is the column vector, so it has to be represented like this: 3 2 6. So where 3 2 and 6 represent the end of each row, and then I will put enter. So in this case the column vector will be 3 2 6. On the other hand, the matrix can be also by represented by the same. So matrix, so for example, I want the sample matrix. My sample matrix is a 3 by 3 matrix. So for the 3 by 3 matrix, I will first define the first row, then second row, then the third row, like this. So I will start with the square bracket, and then say the members, the first row is 4 6 7 4 6 7, and then this is the first row, and then I will put the colon to indicate the end of the first row, and then the start of the second row. So the second row is, say, maybe 3 8 9. So you can see that for the row I will put the numbers with spaces, and then for the next row I will put the semicolon, and the third row is, say, 0 3 6. Okay, and now I will close the bracket. So now I will hit the enter button, and then you can see that my sample matrix is 5 6 7 3 8 9 0 3 6 in the standard format. Okay, so now it's some good time to extract some of the numbers from the matrix. So for example, if I write, if I want to extract this number 8, which is the member in the second row and second column, so I will put like this. So sample matrix, and then I will put the parenthesis. Okay, not the bracket, I will put the parenthesis, and in this parenthesis I will specify the position of this number 8. So it is in the second row, second column, bracket close, and then I will get this number 8. So in this way I can specify some specific number in the I can call any some number by its index number as well. So for example, its index number is 5. For example, for this member 5, the index number is 1, then 2 3 4 5 6 7. So for example, if I want to recall this 0, so then what I can do is I can go to this command, okay, and then instead of 2 I can just put like index number as 7, and then it will return me a number 7 from here, so which will be like 1 2 3 4 5 6 7. Okay, so for example, if I want to recall this 5, okay, so sample and then it will be, if I take the index number 5, so answer should be 8. Yes, so the index number in the matrix goes like this: 1 2 3 4 5 6. So column wise we go into the index number. Okay, and okay, so if for example I want to extract this second column, so in this case how I will go, so I will recall this from the history. So I will recall the sample matrix. If I want to recall extract this second column. So it means that I want to, for the second column will include all the rows. So for all the rows, I will put the colon over here, colon, and then I will press a comma, and then I will put the column number that will be set. So that will recall the second column. So you can see that 683 has been recalled over here. If I want to recall the third row, okay, so then I will put like this sample, and then in this case for the third row, it means that I need all the columns. So for all the columns, I will put the colon. So the third row, so third row, and then all columns, so comma, and then I will put the colon. So it will recall the 036. So you can see that 036 was the third row, and then I have extracted the third row from this matrix. So in this way, we can recall some certain areas of the matrices from a given matrix. See, okay, let's clear the screen, and then I go to this command sample matrix. Let me recall this sample matrix. So suppose I just want to extract these two numbers, 3 and 6. So these two numbers, 3 and 6, are located in the third row, okay, and but are in the second and the third column. So in this case, how I can locate it? So maybe sample matrix, and then because this is in the third row, and then second and third column. So second to third column. Okay, so I will put two column 3. Okay, and then I can see that 3 and 6. If I, for example, I want to recall 7 and 9 from here, or 6 and 8, okay, maybe 6 and 8. So what I will do is sample, and then 6 and 8. So 6 and 8 are in the second column, okay, and but in the first and second row. So 1 to 2, first and second row, comma, and then second column. So it will be 1 colon 2, 2. So 6 and 8 has been recalled. Okay, so in this way you can recall some of the members in the matrices. So here you can see that in the workspace, all the variables which I have defined up to now are the double variables. So double variables are nothing, just like the a name for the floating point format of the number, which will have the 64-bit space to store each number. Okay. Okay, let's see how some of the constants are represented in MATLAB. So for example, I represent a numerical constant as pi. Okay, pi number. Okay, I say pi number. So for this, the simple command used in MATLAB is pi. So pi number is represented by pi. So in this case, you can see that the pi number, that is the value pi, is 3.1416. But in this case, you can see that only 5 significant digits have been shown over here. If you want to show some more significant digits, so I can change the format to long, okay, and then it will show the more significant digits. So I will press format long, and then I will recall that command pi number is equal to pi. So now I will execute it. So in this case, now it is now showing, I don't know, maybe 16 16 significant digits for the pi. So if you want to keep showing number like this, so you can keep it like this, or if you just want the default short format, so then maybe you can change to format short, okay, and then enter, and then now I try again, pi, yeah, pi number, so it is again showing like this. So I have briefly mentioned that the class of these default class of the numbers, which is which is used in the MATLAB, is the double point. Sorry, a double precision numbers, or double, which means that the 64-bit numbers. But if you want to save space of if you don't want the precision to be not so high, then you can change the class of the number from the double precision to the single precision. So for that, I think you can use the command as single. So for example, uh, if I want to represent this pi number into single, so single format pi, okay, single pi, I can say single pi. So in this case, what I can do is I can use this single command from the MATLAB, and then I can use the uh, pi number, pi number, number, and then close it in the bracket, and yes, pi number, and then it is showing as the variable, the value of the pi 3.1416 has been stored in a variable named single pi, and it is also showing that over here that it is stored in the workspace as a single class number, which shows that it is now a 32-bit number, 32-bit number, instead of the other numbers as 64-bit numbers. So with this some short introduction about the variables and some basic calculations in MATLAB, let's talk about a little bit about the scripts. So let me clear the screen, clear all, okay, and clear the screen. Everything is cleared. So for the scripts, maybe you can make the script by clicking in the current folder window, and then new, and then script, okay, and then you will give the script some name. Maybe you can say that let's start, okay, let's start, and you can see that the script has the name as the .m extension, okay. So this is the standard extension in MATLAB for the scripts. So now if I want to open this script, so then I can double click, and then it can open in the editor window. So let's start script. So I can double click, and then it will go to the editor for the script. So in the script you can write your commands. So normally when you write the script, you also add the comments. So for adding the comments, you will start with the %sign, okay, and then it will show that it is a comment window. So comment is not executed by the program. So comment, so maybe you can put like this is the first script, okay, and then I can add more commands. So maybe I want to just say display some message, display dis. So for this I will use the disp command from MATLAB, and display, and then I want to display a message, welcome to learn MATLAB, okay, any message we can put. So I will put this message, and then I can this short program. So to just check it, then I can see that over here I can put click this run button over here, okay, and I can click this run button. MATLAB can only run a file with a valid name. MATLAB name must start with a letter and contain only letters, numbers, or underscores. So it shows that I have put this name as incorrect. So maybe I should correct it. Okay, so I should correct this name. because I put a space over here. Okay, so now maybe I can try it. Okay, so now the purpose of this script was to display this welcome to learn MATLAB. So to see if this script can display this message, so we will click the run button over here, and then we can see that this has started. Welcome to learn MATLAB. Okay, so if I click again, let's start the name of this script, and then I will hit enter, so the message will display. So it means that in this way we can create this script. Remember that this script is just a text editor file, so you can create it in any text editor and save it as a .m extension, and then you can run it in the MATLAB. You can modify the script as and when you like. So for example, now in this script I have this this script only displays the MATLAB, so maybe I can input some more commands. So maybe I create a matrix, random matrix. Okay, so I want to create a random matrix. So in this case I can use so that means I want to create a matrix, say 3 by 3 matrix with the random integer. So for this I will use the MATLAB command rand I, and then rand I, and then I want a 3 by 3 matrix, so I will put 3, 3 and bracket close, and now I will run it. So yeah, so I will run. Let's start. Okay, or maybe I think I need to save it first. Okay, so after I save it, so then I will run it, then you can see that a random matrix has been created over here. Okay, if I put a colon over here, and then I hit the save button, and then I run it again, so then in this case that column that semicolon over here has suppressed this output. Only the output for the welcome to learn MATLAB has been shown. So at this point, if I, for example, I want the transpose of this matrix. So for this, it's a very simple command over here. So transpose, okay. And then if I want to save it in the transpose, so I will just put like random matrix, and I will put an apostrophe over here like this. Okay, just this symbol. Okay, apostrophe, and then I will save the script, and then I can now execute the command. So you can see that 113 312 and then 132 112. So both the original matrix and the transpose have been displayed over here. So you can see over here that so the command for the transpose in MATLAB is very simple. This apostrophe is placed after the name of the matrix. Remember that I can suppress the results of these two commands. So for example, over here semicolon, I can put semicolon over here and semicolon over here, and let me clear this screen, and then let me run. I run the script again. The script has been saved, and now I run the script, and I can see that now the input of these two matrices have been suppressed in the command window, but this input is still available in the workspace. Okay, so that means this semicolon suppresses the results in the command window, but inside in the workspace of the MATLAB, the results are still available. Okay, Okay, so you can create many special matrices in the um, MATLAB. So for example, if I want to create a matrix of all zeros, then I can also create it. So maybe I can change this script. So for this, I don't, for changing this script, I just want to don't execute these commands for the time being. Okay, so what I can do is I can execute, select these commands and right click and then make these commands as the comments. So all of these are now the comments, and now I can enter the new script values. Although it's not necessary, it's just for your information that any of the executable commands can be made to be made as the comments in the script. So here, if for example I want to create a zeros matrix, so for example zero matrix, so zero, I say it as 0m. Okay, 0m is a zeros matrix. So for this, the command is MATLAB command is zeros. Okay, zeros. Okay, and say I want a zeros matrix, say 3 by 4. Okay, 3 by 4 zeros matrix, and then I save the script and now run the command. So you can see that this 3 by 4 zeros matrix has been created. If I want to create the identity, so not the identity, the matrix including all ones, so I can use also the command by the MATLAB. So for the ones matrix, so ones matrix is equal to ones. Okay, maybe I want the ones matrix, say 5 by 5. Okay, so execute it, and yeah, here I have made some mistakes. So it is ones is not a one is not a command, ones is a command. Okay, so I should correct it, change it, and then clear screen, and now I will execute. This I can suppress, just shows the ones. So yeah, so you can see that now the matrix of 5 by 5 matrix of ones have been created. The significance of creating these ones and zeros matrices is that for large calculations, it is easier to first create those ones and zeros matrix first, because it takes less time for the program to create it and then populate these ones and zeros matrix with our desired values later on, rather than create the desired values from the scratch before. Thing is about getting the help of some functions or commands, is that one way of that getting help is that, for example, if I want to get some help about this ones function, so I can just double click it and write, and then I click the help on ones. Okay, help on ones, so it will show me the various the information and some of the examples how I can use this command on the MATLAB. So it's very useful way to get the help. Okay, and some of the commands which are related with this function are also given in this help topic. For example, this 5 by 5 matrix is easier to show over here. So, but just for example, if I create a 50 by 50 matrix of ones, okay, then it is not very convenient to show it in the command window over here. Then we can put the semicolon over here, and now I run the script. Of course, nothing will show over here, but here I can see that this 1m is this. Okay, this is the 50 by 50 value. So if I double click over here, then it will open another window, so which will be like more like a Excel type of window. So this window will show you the how the data has been created in the spreadsheet format. So if you want to examine data, then it will be better to examine in this spreadsheet format over here by just double clicking the values in the workspace area, double clicking the variable in the workspace area. You have reviewed this worksheet, then you can just close it by clicking this button. Okay, so now I will talk about the matrix multiplication. So for this I don't need to use the script, so I will close the script window and then I will clear all workspace and CLC, clear the command window. So if I want to illustrate the matrix multiplication, I need to first define two matrices. So I can define the matrix 1, mat1 is equal to, say, 1, 2. For the simplicity, I just take like 1 2 by 2 matrix and then 6, 3. Okay, so this is the matrix 1, and then I express its output. Then I choose the mat2 and I define it like 2, 5, semicolon 5, 2. Okay, 2, 5, 5, 2. Okay, and then I express its output as well. So I want to multiply these two matrices. So for the multiplication, maybe I put like prod, okay, product m1 m2, okay, product of these two matrices, mat1, and then for the multiplication I will use the dot operator, okay, just the full stop or period, and then I will put mat2, mat1, mat2. This time I don't express the result, and then dot indexing is not supported for variables of this type. I got the error, of course, because dot is not the default operator for matrix multiplication in MATLAB. Dot is the operator in the Wolfram Mathematica, but not here. So let me correct it. Here it is the asterisk, okay, asterisk. And now when asterisk, then I can see that this is the product of these two matrices, and then of course you can very easily verify it. So for example, this 12 is like 1 times 2 is 2, and then 2 times 5 is 10. So 10 plus 2 is 12, yes, and then similarly for other functions. Okay, so however, this dot operator we still can use this with in MATLAB, but dot operator we can use with the asterisk operator. So dot asterisk. So what will that dot asterisk will do? Dot asterisk will do that will what this operator will do is it will multiply these two matrix element wise. So for example, if I execute it, then I will get this element product as like this. So now I have element product. So it will be like 1 times 2 is 2, 2 times 5 is 10, okay, 6 times 5 is 30, and 3 times 2 is 6. So I will get the element wise multiplication. MATLAB can do the element wise division as well. So for example, division, like I say division m1 by matrix 1 by m2. So instead of asterisk, I can put the slash and then I can execute this command. So in this way it will perform the division. So it will be 1 divided by 2, 0.5, you can see, and then 2 divided by 5, 0.4. So you will get this. Okay, now let's have some exercise on if statement. Okay, in MATLAB. So clear all and CLC clear screen. Okay, so let's start a new script for the if statement. I can give this name as grades, okay, because I will be using this if statement to calculate the grades. Okay, so the if statement can this script, I can double click and then I can go to the editor window. So in the editor window, maybe I can put some comment that this script calculates grades. Okay, so it's very simple. For example, if the grade is between 50 and 100, it will be pass. If the grade is between 0 and 100, it will be fail. Okay, so first of all, there should be an input. So input I will place into the grade. Okay, okay, maybe okay, grade or marks. Okay, what are the marks? Marks is equal to input, and then input is a command from MATLAB. Okay, so input will prompt enter the marks. Okay, enter the marks from 0 to 100. Okay, and what I can do is I can put a colon over here and I can give a space and then close this parenthesis and then suppress its input. Okay, and next I will now check this input first. So if marks are greater than 100, okay, if the marks are greater than 100, then I think there should be an error message display. So display, so DISP is also the command from MATLAB. So display that invalid grade. Okay, this will be displayed. Okay, if marks are else if marks are what you can say less than 0, so maybe we can input a negative number as well. So then we can also display invalid grade. So I can copy and paste it. So in this case, if the marks are greater than 0, then also invalid grade. So else if, okay, else if marks are greater than or equal to 50, and so for and we will use double ampersand sign, and marks are less than or equal to 100. So I can put these two conditions into the parentheses. It will be better to put them so that here, if the marks are greater than or equal to 50 and marks are less than or equal to 100, then what will be display? We will display that these are passing marks. Okay, because between 50 and 100 are the passing marks, so this will be displayed. Else, now there is no other option which is left, so else we will display that these are failing marks. Okay, that means that is between that will, because other situation which is left is that marks will be between 0 and 100. Okay, so these are failing marks, and then there is no other option left in this case, so I will put and then it will be like that. Okay, so in this way, if everything has been done correctly, the if statement has been completed. So I will save it and then I will run it. So now here I can see that in the command prompt it is asking enter the marks from 0 to 100, although it's saying that enter the marks from 0 to 100, but I still can enter the marks outside of this range. So let me add first a mark between like 40. So 40 should be fail. Okay, so these are failing marks, so I'm missing this R over here, so R. Okay, so that's fine. Then I run again, enter the marks from 0 to 100. So maybe I enter 67 in this case. Yeah, these are passing marks. Okay, now in this case I run again, enter the marks from 0 to 100. I enter 110, but this is the message has come that this is an invalid grade. In fact, it should be invalid marks. Okay, invalid marks. Invalid marks. Okay, yeah, because we are talking about the marks. Okay, so now I run again, and not on I can run it by by typing the name of the file as well. So name of the file is grades, grades. Okay, and then enter the name. So in this case maybe I enter -4. So these are the invalid marks. So in this way you can see that if statement you can type. So you can see that if statement is working with the if, else if, and end will mean that this will end the process. Okay, and we are also using that and to check if either of these two statements are meeting. Okay, another statement which is very useful in MATLAB is the switch statement. So let's see the use of the switch statement in this script. So switch example. Switch example. Okay, so I double click it and open it in the editor. So comment switch example. Okay, maybe I take the first value as a number. Okay, so I say this number as the A. Number A is equal to input, enter first number, colon, space, apostrophe, bracket close, and then semicolon, and then I ask for another number to enter after the first number. I call this as number B. Number B, input second number. After that, what I want is that maybe since I have two numbers, so maybe I want to add those numbers, I want to subtract numbers, or take the average. So I may have some different cases. So in this case, I take these three cases. Okay, add, subtract, and average. So I define the action. Okay, action is equal to input. Action is equal to input, and ask what action to perform. What action to perform? What action to perform? What action to perform? So enter 1 for addition. Okay. 2 for subtraction, and or 3 for average. Okay, we can have even more cases, but just for illustration purpose, this may be okay enough. So colon, space, apostrophe, enter, and then I will close it. Okay, so now I will enter the switch statement, switch, and we are now switching between different actions. Switch action, and then switch will have cases. So case case. So if case is entered as 1, then that means we have to add. Okay, so addition. So addition is equal to a plus b. Addition is equal to a plus b. Then next is case 2, subtraction is equal to a minus b. Addition is equal to a plus b. Subtraction is equal to a minus b. And case 3 is equal to case 3 is 3. Sorry, case, and then the next one is case 3. Case, so we have to enter either 1, 2, or 3. If they want to enter add, then 1, then subtract, then 2, and then average, then 3. So average. So average of two numbers is equal to a plus b divided by 2. Okay, so these are the three possible cases. If any other cases, then we will use otherwise. Otherwise we will display invalid case entered. Okay, invalid case entered, and then we will end it. Okay, so with this switch statement will complete. So let's check it. So save it first, and then I run it. So it is I enter the first number 3, I enter the second number 4, I enter the action. If I want average, so 3. So 3 plus 4 is 7. 3.75. Okay, so in this way it will work. Okay, I run again. 5, 7. Now I want to subtract, so I will enter 2. So it will be. Okay, so now I'm going to show you the for loop. Okay, so create the script for loop, and I double click to open the editor. So comment is for loop. So for loop is for. Okay, so it starts from the index, okay, number. So for example, if the index over here, I take index to 1 to 20. Okay, that means I want to repeat this loop for 20 times, and each time I want to display that index number. Okay, so you can do more sophisticated things inside of the loop, but for this example I'm just showing the simple case, and then end. So what this loop will say, it will take the index value of 1 first, and then it will display it, and then it will go and then increment that index value by 1, and then it will display number 2, and then it will take an increment value of 1, and then it will display 2, and then until the last value of 20 that will be reached. So let's run this loop, and then I can see over here it has generated numbers from 1 to 20. So this type of stepping by 1 is default. So we can you can also change this stepping by, say, some other number, say 2. Okay, so maybe the values are changing from 1 to 3 to 5, like that. So if I input 2 and then enclose by columns on both sides, and then I run the script, then what I will get these numbers. Okay, 1, 3, 5, 7, 9, 11, 13. And we can also define these parameters 1 to 20 outside of the loop as well. So for example, if say if I take a number, say like C equal to 25, okay? And the increment I mentioned as step increment I take like 3. Okay, so I can change this loop, and then I can say that the step, instead of 3 I can put step. Okay, and then instead of 20 I can put C. Okay, and then I can run it, and then it will be over here. So in this case it will run like, so 1 4 3 1 4, okay, in steps of C. So now let me show you again. CLC. Okay, if I run it again, so it will be like 3. Yeah, so first two values are the C and step values. Okay, and then the sequence is 1 4 7 10 13 16 20 and 25. Okay, we can even suppress these values to not show them. Okay, so close and run it, and then it will be like, you can see, for loop 1 4 7 10 13. So the in the steps of 3 the values are printing. So now I will show you the while loop. So I close this, and then clear all, clear screen, and I create a script, while loop. Okay, while loop, and I open the editor. So comment is while loop. Okay, so while loop, let me show you the example. So for example, if I have a number, say num1, okay, is equal to 35, and I define another number, say n is equal to say 3, okay, and now I start the while loop. So while this number1 and um1 is greater than 0, that means it is a positive number, then what I can do is I can reduce this number by n. Number 1 is equal to number 1 minus n, okay, and then I will display the this number num1 num1, okay, so I will display this number and then end of the loop. So here I will run it, and then I can see over here is how this. I can do one more thing, is that I can suppress this over here n, and similarly this n I can also suppress it, so that we can only display these numbers while the loop is running. So now I run it. So in this case I can see that the while loop is like 32, 29, 26, 23, increasing by 3, but the last value is -1, which is correct, because num1 minus, because when the value was 2, it was reduced by 3 and then it was displayed, and after that now the num value is less than 0, so it is not going to be displayed. So it the loop is finished over here. So this while loop can also be used for breaking the sequence of operations. Okay, so let me show you. Let's make all this as comments and write another script. Okay, so for this what I want to show you is that, so for example, if the condition is true, so for example, while the condition is true, okay, true, true, while the condition is true, in what sense it is true? So for example, if we generate a number, okay, num number, okay, num, and if you generate any number and that is a random number up to say 15, okay, if we generate a random number up to say 15 and then we suppress it, but what we want is that a system can generate a random number up to 15, but what we want is that if, for example, the random number generated is say more than 10, okay, we're just taking some hypothetical example, there may be some practical uses for that. If, for example, if the number generated is more than 10, we want to stop this process, okay, so in this case we will use an if statement over here, and if number, that is the generated number, is greater than 10, we want to stop the process, okay, want to stop the process. So in this case, but we want, before we want to stop the process, so for stopping the process, then we will use the term break, and we will use the command break, okay, but before break we want that also we want to display that as well. So display, okay, display display that the number has exceeded the limit. Okay, the number has exceeded the limit. Okay, the number has exceeded the limit. Okay, the random number generated. So that's why we are breaking this process. So if we break it, and then otherwise the process will be broken. So in this case, because we are using the if and break statement, then we will end it. So this will be the end of the if statement, and otherwise we will display the generated number is fine. Okay, the generated number is fine, or we can just display the number itself as well. So we can display this number itself. Okay, so it will be always, the displayed number will be always uh, less than or equal to 10. Okay, you can always display the number as 10. Okay, so then now end. So this will be the end for the while loop. Okay, let's run this command. Before I run, then I can clear it. Okay, so let me show it. So I run it. Yeah, so in the while loop, what has been created? So 3 and 4 numbers were generated, and then in the third time the number has exceeded the limit. Okay, and then you can see that, so 4 and then the number has exceeded the limit. Okay, let's see one more time. In this case 4 and then the number has exceeded the limit, and then again in this time you see 6, 3, 4, 10, 8, 6. So then the exceeding of the limit has achieved. So in this way, this is a kind of like a fun way for representing this while loop. So now let's try to develop some functions. Okay, so are very useful in the MATLAB. There are of course many inbuilt functions, and some of the functions which you can also create, like we can say that the user functions. Okay, so let's close this everything over here, clear all, and CLC. So for function, maybe I will start from here. I will click new, and then now I will select function. Okay, so I give this function a name, first func. Okay, so when you open the function for the first time, by this double clicking this first func, you will get this kind of like a structure of the function is given to you. So in this case, I am thinking to create a function for the calculation of the length of the hypotenuse of the right angled triangle. So in this case, in this function, I have these two square brackets. So these two square brackets are important, and in this case I define the hypotenuse as the length c. And on this, on the other hand, over here in the input argument are the lengths of the sides A and B. So I can remove this. So in this way, I will define this function. So A and B. are the two functions. And this is the comment line, so I can just leave it like this. And here is the output. So here I will provide the output. So the output will be the some formula. So for example, the length c is equal to so here we define the formula for c. So c is equal to the square root of a square plus b square, a square plus b square, and that is the square root. So you can express this value. So in this case, you can see that function, although these are the comments line, maybe we can just delete. These are not necessary. So some function structure has two parts. First is the definition of the function. Definition means we define what is the independent variable, what is the dependent variable, in this case is c, and what are the independent variables, in this case a and b. And then we define the relationship between c and the relationship between the dependent and independent variables, and that completes the function. So in this case we can save it, and now I can run the function. So for running the function, I will need to call the name of the function. So the name of the function is first fun, okay, which incidentally was the file name as well, but you can also have different name as well. So first fun, okay, first is the name, and then I need to call the arguments. So the arguments are a and b. A and b are the sides of the triangle. So for example, if the sides of the triangles are 3 and 4, I need to write, and then I need to enter it. So the answer is b. So the answer in this case is 5. Okay, so we can provide the more explicit answer as something like this. We can write 8 answer is equal to 5. So which in fact is correct. So because we know that for a right angle triangle with sides 3 and 4, the length of the hypotenuse is 5. After the function, let's look at how we can how we can import the external data. So in the current folder, I have copied one file sine.csv. This is a file in which I have stored some data. So how we can read this data in the MATLAB. So for this purpose, I can assign the data of this file to a variable. So maybe I can say that my data equal to, and then in order to read this file, I can say that I will use the function csv read, csv read, in brackets. I will put the file name in the within these commas, within these apostrophes, sine dot csv, which is the file name, and then parenthesis closed, and then I will express its output, and then I will press enter. So here I will see that in the workspace I have this variable name my data, which is 630 by 2 variable. So it means that it has 630 rows and 2 columns, the data, and it is already stored as a double precision 64-bit data. So if we want to see it, what that data is, then we can double click it, and then it will show the preview of the worksheet for the data which has been stored over here. Okay, in order to look at how this data looks like, that means how is this data is visualized. So I can plot this data. So I can plot this data. So in order to plot this, because I know that the data has been stored in this variable my data, and that variable has 630 rows and 2 columns. So if I want to all the data in this variable, so maybe I can say I want to plot the first column. So in this case I have to call all the rows and the first column, so in this way. So and then if I hit enter now, so I will see that a separate figure will appear over here with this plot. Okay, if on the other hand I want to plot the second column over here, then it will be, and now I hit enter, and you can see that this is a sine wave that it will be plotted. MATLAB has some functionalities about the debugging of the scripts. So for example, if I take this script which we just developed before, and if I want to debug that strip, that means if I want to investigate that strip, so what I can do is in this strip script, it is a while loop, and in this while loop I want to check what is the value of the number which was investigated before this message will be displayed. So what I can do is I can just click it over here, and then it will show a red dot over here. That will be the breakpoint. Okay, we have set the breakpoint over here. So now the if I will run this script, the commands only up to this breakpoint will be run. So now I click it, and then I can see that this command prompt over here is shown with this letter K, which shows that it is being a breakpoint is being used over here. So at this breakpoint, the value of the num was calculated. So what was the value of num? So value of num is 6 over here. And now if I continue from this point, so the output should be 6, because num was less than 10. It was not less than 10. If it is greater than 10, then this number has exceeded the limit that message will display. So from this point I can further continue it, and now the number 9 will be generated, because at that point maybe the number value was 9. Okay, so maybe I continue without the breakpoint over here. So then 218, and then it was created. So now it has gone back to this mode, and let's now check the breakpoint again. Okay, maybe put the breakpoint again, and then I run it, and then I check the value of the num before the displacement before displaying any message. So now it is 15, and then if I continue it, the message number has exceeded the limit will be displayed over here. So in this way we can okay, now let's check the performance of our code, so with the help of one example. So let me clear all and CLC, and then I close this edit window, and I create a new script. Okay, so I say that it is a performance performance script. Okay, and oh no, it is the wrong one. performance is here. Yeah, so for the performance script, I will first of all create a for loop. So for I is equal to 1 to 1 million. So 1 2 3 4 5 6. So as you can see that it is a very big vector that I will be going to create. So it will be showing that I will create a vector with the name name I, sorry, with name AI. That will be created. So vector will be with ith place, and then each vector will be the ith place. So I will close it, and then I will end the loop. So as you can see that this matrix will be 1 million elements long. It will be a column matrix. So if we want to know that how long will it take for this matrix to produce, so I can enclose this code into a command which starts from tick and then tick tock. Okay, and then I can execute this code. Okay, yeah, so I can execute this code, and then so it will say that the performance will show that the elapsed time is 0.097103 seconds. That means about 97 millisecond. It will take about 97 millisecond for this code to generate. Okay. On the other hand, if I do a small modification, is that if I can create a matrix with all zeros, so I is equal to zeros. Okay, zeros from 1 to 1 million. Okay, so here we are creating a matrix M with zeros, and then it has like 1 to 1 million elements. So in this case, if I run this script, then what will be the elapsed time? So the elapsed time in this case will be 0.009057 milliseconds. That means only 9 milliseconds. So from 97 milliseconds to about 9 milliseconds. So there is a much greater, there is a much quite a lot of reduction in the processing time for this code when we just pre-allocated the space for M in M over here for the matrix M. Okay, so now let's plot some charts. Okay, so clear all and CLC. So okay, so for plotting, I will plot the chart from the sine.csv file. Okay, so it is first of all I will allocate the data of this file into a variable. So it is the csv read. Okay, and the file name is sine.csv. Okay, and and then semicolon. Next, I know that because in this chart there are two columns, so I will allocate the first column as x values. So I will take x is equal to my data, and I will call, so x is equal to my data, and then column, which means that I will take all the rows and then first column, and then I will take this y value, my data, all the columns of the first vector, and then all the rows of the first vector, and then the second column. So in this way, x values will include all the values from the first column, and the y values will include all the values from the second column. And next, what we can do is I can plot the data. Okay, now I can plot x and y. So plot x comma y, and then I execute this command. So in this case, I get a value which is figure 1, in which shows a straight line. However, I think it should be plot xy, not yy. So I made a mistake over here, and then I can put x. And now I execute the command. And I can show the figure. Yes. So this will show up in the figure. Okay. So this is the sine curve. And with the grid on command, we can turn the grids on. Okay. So for example, grid off, then the grids will be off. Now there are no more grids. If it is grid on, now the grids are on. With the axis tight command, we can tightly fit the axis on left and right. Okay. So now in this plot, if I want to change the limits of the y axis, so I can change like this. So for example, instead of -1 to 1, I may say that the limits of y should range from -1.5 to 1.5. So for this, I will use the y limit command, ylim command, and for this, for the identification of the limits, I will input into the vector -1.5, 1.5, and then bracket close, enter, and now I will see this plot. So I can see that the limits are from -1.5 to 1.5. So I can see that I have executed this command plot xy with this in apostrophes. I put the red, so the color of this line has changed to red. Or maybe if I want some other color, So then I can execute this command again, and then I can put say M, which is for magenta, and I can see the change like this. Okay, so I can make various changes over here. If I want to show some of the markers, for example, circular markers over here, so then maybe with O I can M I can put a letter O. O will be for the circle. So it will show like this. Okay. We can also put some X and Y labels as well. So for example, X label, I don't know, maybe if it is a like a time. So for example, if the X label is time, so then we can put it like this. Okay, and maybe the time is in seconds. So this will be the X label. And then if I want to put the Y label, so Y label, and then maybe just suppose that if it is a speed, so this is the speed, and the speed is in meter per second, okay, and I can put like this. So let's see how the labels look like. Yeah, speed in meter per second, time in seconds. If you want to put the title to this plot, then you can use the title function, and you can put any title. So for example, speed versus time plot. Okay, so that may be the title. Okay, speed versus time plot. So let's see how it looks like. Yeah, speed versus time plot. Similarly, we can put a legend on this chart as well. But for this legend, it is better to have two plots, not just one plot. So maybe I can plot another chart on this plot. Plot x versus 0.5 times y. That is, the other plot is x, and then the y values are half. And then I can plot it with some other symbols, maybe black lines. Okay, black lines, and then with these triangular markers. Okay, so hopefully a second plot will appear on this chart. In order for the second chart to appear, I think because we need to apply the hold on statement. Okay, so I will apply the hold on statement, and then I will input this plot curve like this. Yes, again, and then I will plot it, and then I think it will show like this. So this hold on command will allow another plot to be drawn on the existing plot. Okay, So in this case we have two plots over here. So now I want to show the legend. So legend, okay, so the legend I can show by this command, and there are two plots. So for the first plot, maybe I can say that the half half y, okay, because it was 0.5y, and the second plot is full y, full y, okay. So I can show it over here. So let me see it over here. So then I can see that the half y is represented by the triangles, full y is represented by the circles. So in this way, then I can do various changes into the plots. And in the end, remember to that turn the hold command off. Okay. Okay, so that was some introduction about the MATLAB. You can further do some further self-learning by the MATLAB by the resources available on the MATLAB website. So for example, even in this MATLAB program, there is this button over here. You can click this button and then it will open a new page over here. And then in this case, you can see that you can self-learn some of the pages, some of the courses. For example, over here, MATLAB on ramp. Okay, so it is the introduction to the MATLAB. So, and some other courses, maybe machine learning with MATLAB, deep learning with MATLAB, image processing, okay, and then core MATLAB, MATLAB fundamentals, okay, and in the data science, and then for your courses, for example, nonlinear equations with MATLAB, okay, ordinary differential equations with MATLAB, so you can perform introduction to linear algebra with MATLAB. So so a lot of courses are available which you can self-learn on this MATLAB and using the MATLAB website.